Today, I would like to present on the Steve Collins Department Seminar, Designing Robotic Prostheses and Exoskeletons that Improve Human Mobility. So his central research goal is to develop wearable devices that improve human mobility, and particularly for people with disabilities that affect the lower limbs, like amputation or stroke, or for people that have to walk long distances. So he used three complementary approaches. First, they developed new tools to speed and systemize the design of prostheses and exoskeletons. And they call this universal device emulators. And the second, they leverage emulators to perform basic scientific experiments aimed at discovering and characterizing the effects of new assistance strategies. Third, they take successful approaches and try to translate them into mobile devices with focus on highly energy efficient robotics. So first start with emulators, and why they want to develop these tools, and because for the traditional approach, the first problem with the traditional design approach is that usually it does not work. We wanted to see a reduction in metabolic rate. Instead, we see an increase in the metabolic rate by 7%, and this happens most of the time. For the second problem with the traditional design approach is that these two, they developed this very bad at testing those ideas. It took them 5 years between having the idea and having something robust enough for test. And they confronted with tight constraints on energy cost and the size and mass. So they end up with something that's very specialized. So they want to make this device to take realistically on the order of years. It turns out that little differences in device function can have a big impact on high-level performance. So after their experiment, they don't even know whether energy recycling is beneficial. So looking back over this approach, and the first solution is that they need simple models. They need observations for biomechanics to inspire interventions, but they should not expect them to work the first time because people are very complicated and it's difficult to predict. So how people respond to different interventions is very complicated, and they think they need to do experiments, a lot of experiments in rapid iteration. So the second thing is that the primary factor limiting the speed with which they can do these experiments are the experiment tools. They are using these product prototypes. They are cumbersome and they are a rate limiting factor. So they design a new way of developing these tools based on universal device emulators. So the basic idea is to take a process that usually requires a long time and compress it to a short time. So they can test a lot of ideas really quickly. Uh, so um, their system typically have three main components: the powerful off-board motor and control hardware, lightweight instrumented and effectors worn on the leg, and a flexible tether connecting the two. So having this powerful off-board hardware means they are not limited by the actuation and processing. There are a couple of two servo motors with 30 kilograms, but it's off the body. Here we have a real-time processor, so you don't have to worry about decoupling these things. So this makes the end effector simple and lightweight. This maybe this looks complicated, but it's just a few pieces of aluminum revolute joints and an encoder to measure the and an angle strain gauge to measure or spring deflection measurement to get the torque, and you can end up with something that weighs about 1 kilogram, about a third of the mass of the other powered processes. So this is a device with two independently controlled toes. So when you move them together, you get the plantar flexion, and when you move them in the opposite directions, you get something like inversion, inversion. So they use this to probe balance and in the frontal plane. And here's another set of end effectors that mm, these are the ankle exoskeletons. They used to look at the augmentation of intact people and the people who have a stroke. So for the future work, they plan to continue to develop more end effectors to increase the kinds of interventions they can explore. For example, the new exoskeletons and processes, the multi-actuated prosthetic feet, and ultra lightweight exoskeletons for fast running. So they will get a complete lower limb system in next few years. They are also looking at other modalities. For example, this device use pressured air to shoot big steel balls into the chamber worn on the ankle, so they can into and out of the chamber on the ankle to change the mass of the leg by a couple of kilograms in less than a second. And finally, they are looking at the emulating aspects of the environment. This is a push board which can provide tucks and trips in various ways unexpectedly during walking. They want to use this to develop assessments of balance. So one way to see how stable person is to shove them harder and shove them harder until they fall down. So he is also interested in the commercial translation. His former PhD student has started a company, the Human Motion Technologies, and they have already made a couple sales of their emulator system to other laboratories.